Okay. Got three equations that we could get from 3 points in a, like a flow thing from the cylinder, right? And then I ask you to subtract the first, do the first equation minus the second equation, right? Okay, so the first equation is this. Right there it is, right there it is, right? If you subtract the second equation, then you're going to have a minus 36a and a minus 6b and a minus c and a minus 40, right? So you could write that as minus 36a minus 6b minus c equals negative 40. Now you just have 16 and negative 36 is negative 20. That's minus 2b. C's go away. C and the negative C is just 0. And this is 50. Is that clear? Now if you want to write it out in linear form, which is fine, and many of you did, you could also say, okay, let's see, 16a plus 4b plus c equals 90. Now this really isn't good form, but the idea is good, so I'm going to acknowledge it anyway. And okay, so I write the first equation and then minus the second, right? Again, that's notationally a little fuzzy, but the meaning is fairly clear, okay? So I won't yell too much if you do that. You want to put parentheses around this, okay? Then you want to say, okay, well, I got 16a plus 4b plus c equals 90. And then I got minus 36a minus 6b minus c equals negative 40. So now I'd say I've got 16a minus 36a giving me negative 20a. 4b minus 6b giving me the negative 2b. C minus c giving me nothing. And 90 minus 40 giving me 50. Same result. Probably better to do it like this, because distributing through that negative and stuff, I don't know. It's kind of okay either way, but if you got a choice, do this one. Okay, so what do you get for the third equation minus the first equation? Second equation, first equation, whatever I said. Third equation minus the first. Yeah. Yeah, now I can look at this. I'm not. I'll write it out. You get 100a plus 10b plus c equals 20, and then minus 16a and minus 4b minus c equals minus 90. That adds up to 84a. I think this is what you said. Plus 6b equals negative 70. Okay. Well, now what have you got? You got this equation and this equation. And if these equations are true, then these equations have to be true, because you got them by adding two things on this side that are equal to the two things you add on this side. You still have to have equality. So now you've got a system of two equations. You have this one and this one. What happened to C? I'm sorry? What verb did you use? Yeah. It got subtracted, and since you had two of them, it went away, right? So I can say, oh, man, for emphasis, I got to say this in red. C got eliminated mathematically. You didn't eliminate it just by not writing it down anymore, because I saw a lot of people do that, okay, earlier in the term. He eliminated it mathematically, okay. Okay, well, now what do we got to do? We want to find the values of A, B, and C. You're going to want to eliminate either A or B, right? Again, that doesn't mean erase it, and then, you know, it's not how you eliminate. So how are you going to eliminate? Well, first of all, which one do you think you'd rather eliminate? Because the numbers are smaller, right? Okay? Numbers here are smaller. So how am I going to eliminate B? It was easy to eliminate C because I only had a C on each equation, right? I didn't have any difference in the coefficients. The coefficients were always 1, right? So all I had to do was subtract one equation from another, and that took care of C. I can't do that here because I got different numbers in front of A and different numbers in front of B. So how can I make that work?
Multiply one by 3, or the other by, well, divide the other by 3.
If I multiply the first one by 3, then I'm going to have a negative 6b, and I have a 6b here. When I add them, b is going to go away, and I can solve for a, right? So, first times 3 gives me negative 60a minus 6b equals 150. The second equation remains as it is because, of course, it has the plus 6b, and that's what we're picking on. So now when I add these, I don't have a b anymore. I have an equation that just has a in it, and I can solve it easily. Okay, I have 24a equals 80. So a is 80 over 24. Okay, and that reduces down to 10/3. We had that in a previous problem. I had no idea that was going to happen again. Apparently, that number will haunt me here now for a couple of weeks. Okay, you got 10/3, right? Okay, well, now can you find B? Sure. I can take this equation right here, or this one, or this one, or this one. Of course, this is the same as this one. And plug in 10/3 for B and solve for A. I might have time to do that, but I have to do it pretty fast, so I might just leave it to you. Okay? Negative 2 times 10/3 is negative 20/3, right? Well, let's just, because there's something that's worth illustrating here. So let me get a different color so you can follow where I am and what I'm doing. So I'm going to take this. Yep. And then I plugged in for A, not B. I mean, I plugged in for B here when I said the 20/3. That wasn't right. Okay, so I have negative 20 times 10/3 minus 2b equals 50. How do I solve that? Well, first place I have negative 200/3 minus 2b equals 50. And now what do I do? You got any of them D words in this equation? You got a denominator, right? Do you like dealing with fractions? Will you prefer to avoid it when you can? So please do, okay? I don't like dealing with fractions any better than you do. It's just quicker to multiply both sides by 3. I get negative 200 minus 6b equals 150. Multiply by the denominator, thing I've been nagging you to do for a long time. And now we can solve for b. We get negative 6b equals negative 50. b equals 50 over 6, which reduces down to 25 thirds. And now that I've got a and b, I can plug them into any of these equations and solve for c, right? Well, that's the process. You need to nail it this time. I'm not going to go through these again, okay?